Hello everyone. From this class, I will lead you to learn ultrasonic testing instruments and equipment. The components that must be included in an ultrasonic testing system are ultrasonic testing instrument, probe, and comparison test block. Understanding the principle, structure, and function of these devices and the test methods for their performance is the guarantee for the correct selection of flaw detection equipment for effective detection. In this chapter, we will study from the following 5 aspects. First, the ultrasonic detector. Second, the probe. Third, the test block. Fourth, the performance of the ultrasonic inspection system. Now, we will learn the first section, the ultrasonic detector. By learning this course, the following teaching objectives should be achieved. 1. The role of ultrasonic detector. 2. The type of ultrasonic detector. Let's first understand the role of ultrasonic detectors. In the process of ultrasonic testing, the ultrasonic detector first generates a high-frequency electrical signal to the probe, which is converted into an ultrasonic signal through the chip in the probe. When the reflected signal of the defect in the workpiece is transmitted to the probe, the wafer converts it into a high-frequency electrical signal and transmits it back to the ultrasonic detector. However, the electrical signal returned by the probe is weak and contains part of the interference signal, so it needs to be amplified, detected, and filtered by the instrument. It can be seen that in the process of ultrasonic testing, the main functions of the ultrasonic detector can be attributed to 2 points. 1. Generate high-frequency electrical signal and apply them to the transducer to excite the probe to emit ultrasonic waves. 2. The signal is processed and displayed. As the main equipment of ultrasonic testing equipment, like other modern manufacturing equipment in the industry, is a sign that human beings have entered the era of civilization. One of the 4 modernizations is mechanization, which has greatly liberated labor force, improved production efficiency, and served for the benefit of mankind. At present, the types of ultrasonic flaw detectors can be classified according to the characteristics of sound waves, defect display methods, and the number instrument channels. The details are shown in the table 1. According to the ultrasonic characteristics used, it is divided into 3 categories: pulse wave ultrasonic flaw detector, continuous wave ultrasonic flaw detector, and frequency modulated wave ultrasonic flaw detector. An instrument that uses pulsed waves for ultrasonic testing is called pulsed ultrasonic flaw detector, and the pulsed ultrasonic waveform generated by it is shown in the figure. The second is a continuous wave ultrasonic flaw detector. This instrument transmits continuous and constant frequency or periodic changes in a small range ultrasonic waves into the workpiece through the probe and judges whether there are defects and defect size in the workpiece according to the change of the ultrasonic intensity. This kind of instrument has no sensitivity and cannot determine the defect position. It is gradually being replaced by pulse wave flaw detector, which is mainly used for ultrasonic imaging and ultrasonic resonance thickness measurement. The third type is the frequency modulated ultrasonic flaw detector. This instrument transmits continuous ultrasonic waves with periodic frequency changes into the workpiece through the probe, and judges whether the workpiece has defects according to the difference frequency between the transmitted wave and the reflected wave. The real flow detector adopts this principle. However, since it is only suitable for inspecting defects parallel to the detection surface, most of these instruments are replaced by pulse wave flow detectors. According to the defect display method, it can also be divided into three categories. The first category is the A-type display ultrasonic flow detector, which is the most basic display method of the pulse reflection type. On the screen, the amplitude of the reflected wave is represented by the ordinate, and the propagation time of the sound wave is represented by the abscisors. If the ultrasonic wave propagates in a homogeneous material, the speed of sound is constant, and the propagation time can be converted into the propagation distance. Therefore, from the A-type display, the distance of the reflector from the sound incident surface, the depth of the defect displayed when the longitudinal wave is perpendicular to the inspection, and the magnitude of the echo amplitude can be obtained. From the figure, you can see the typical A-type display waveform tested by the pulse reflection method. The pulse T with a high amplitude on the left is called the initial pulse or the initial wave. The pulse signal displayed at the starting position, the high echo B, on the right is called the bottom wave or the bottom echo, which is the reflected wave generated by the ultrasonic wave propagating to the bottom surface of the specimen opposite to the incident surface. The echo F in the middle is reflected echo of the defect. The second type is the B-type ultrasonic flow detector. The B-type display is an image display. The abscisor on the fluorescent screen of the flow detector is the scanning track scanned by the probe controlled by the mechanical device. The ordinate represents the sound wave propagation recorded by the electronic scanning time or distance. So the distribution of defects and the depth of the defects can any longitudinal section of the tested workpiece can be visually displayed as shown in the figure 1. The information that can be obtained in the B-type display includes the location, orientation, and the depth of the defect in this section, and the amplitude of the defect signal represented by the brightness or color of the signal. The last one is the C-type display ultrasonic flow detector. The C-type display is also a kind of image display. The abscisor and ordinate on the flow detector's display screen rely on mechanical scanning to represent the position of the probe on the surface of workpiece, and the brightness of the spot indicates the amplitude of the signal received by the probe. When the probe moves on the surface of the workpiece, the flat image of the defects inside the workpiece is displayed on the display screen, as shown in the figure 1. If the brightness of each point represents the echo propagation time, the defect depth distributed on map, that is the TOF, time of flight map, can be obtained. The information that can be obtained in the C-type display includes the plane position and the orientation of the defect, the amplitude of the defect signal represented by the brightness or color of the signal, and the other information. The B-type and C-type displays are both realized on the basis of the A-type display. The basic principle is determine the signal range to be connected on the A-type display diagram. Use an electronic gate to extract the required signal and use the computer to process and display through A or D conversion. The images and data displayed on the computer screen can be stored, and B defects can be further analyzed and evaluated by software. In addition, according to the number of channels of the instrument, it can be divided into two types: single-channel flow detector and multi-channel flow detector. Single-channel flow detector is operated by one or a pair of probes alone and is currently the most widely used instrument in ultrasonic flow detection. The multi-channel flow detector is composed of multiple pairs of probes working alternatively. Each channel is equivalent to the single-channel flow detector, which is suitable for automatic flow detection. Let's summarize what we have learned about the role and classification of ultrasonic detectors in this lesson. Please review them carefully after class. Thank you.